Good morning, all. In the previous class, we have discussed about the basic terms associated with the electric circuits. In this lecture, we are going to see about the basic circuit elements and also the basic parameters of the circuit that we are going to discuss it. So, as far as the circuit elements are concerned, there are two types of circuit elements are available, or it can be classified into two types: active elements and passive elements. The active elements are those elements which generate or provide energy to the circuit. The passive elements are the elements in which the power will be dissipated or otherwise the power will be stored. So generally the active elements are considered as sources and the passive elements will be considered as loads. So the basic examples of active elements are voltage sources, current sources, the generator. So whatever may be the components that provides voltage or current to a circuit, that is termed as active elements. The passive elements, the examples are the loads, that is nothing but resistor, inductor and capacitor comes under the category of passive elements, in which the resistor dissipates power in the form of heat. Inductor stores energy in the form of magnetic field and capacitor stores energy in the form of electric field. So these three are examples of passive elements. So in the active elements, we have mentioned it as voltage source and current source. So this voltage source and current source can be divided into two types. One is independent source and another one is dependent source. So in the independent source, we have got voltage source and also current source. Why we are calling it as independent source is nothing but it is independent of the current or voltage across any element in the circuit. See here, it will be represented by a circle. And if it is a voltage source, it will be represented with minus and plus. So this represents that A is a potential of higher potential with respect to point B. So this will become plus 5 volt or plus 10 volt, whatever it may be. So always in the symbol it will be represented as circle. And also if it is a voltage source, it will be represented with minus and plus. And the independent current source, it will be represented with an arrow mark. The arrow indicates the direction of current and also the magnitude will be specified. See here also the source is represented with a circle. So these are all independent voltage source and independent current source. So for example, with the current direction, the arrow mark is represented like this. Okay, downwards. So that is nothing but minus. A is with respect to B. That is minus. We can represent it as minus 5 ampere or minus 2 ampere. Next one, dependent sources. So in the dependent sources, we have got dependent voltage source and also dependent current source. Why we are calling it as dependent source is nothing but the voltage or current of the voltage source or current source depends on the voltage or current of any of the element in the circuit. That's why we are calling it as dependent sources. So in the dependent sources, with respect to the voltage source, see here, voltage dependent, or otherwise we can mention it as voltage controlled voltage source. That means the source is a voltage source, but it is controlled by voltage of any of the element in the circuit. And always the dependent sources are concerned, it is represented with the diamond symbol. See here, it is represented with the diamond symbol. And it is a voltage source. That's why it is represented with minus and plus. And it is voltage controlled voltage source. That's why the voltage source, it is a voltage source, but it is controlled by voltage of any of the element in the circuit. Next one, current dependent voltage source. Here it is a voltage source but it is controlled by current of any of the element in the circuit. That may be a current through 8 ohm resistor, or otherwise current through 5 ohm resistor, or otherwise current through a load. That may be anything. But the resultant source is nothing but voltage source. So the diamond symbol represents it's a voltage source. And minus and plus, it may be controlled by current or voltage of the element. That's why we have got two classifications. Next one, dependent current source. That means the source is nothing but current source. See here, it is a current source. That's why we have got arrow mark. And diamond symbol represents that it is a dependent source. Here it is voltage dependent or otherwise voltage controlled current source. That means it is a current source, but it is controlled by voltage of any of the element in the circuit. That may be anything. Second one, current dependent current source. It's a current source. That's why we have got a symbol of arrow mark and also diamond symbol. But here it is controlled by current of any of the element in the circuit. That's why it is represented as I equal to beta into Is. So this is nothing but current dependent current source. So these are the four different types of different dependent sources are there in the circuit. Generally, the sources has been classified into independent and dependent. In independent means it will be represented by a symbol of circle. From that you can able to identify. Dependent source means it will be represented with the symbol of diamond. From that you can able to identify. And if it is a arrow mark, it is a current source. If it is minus and plus, it is nothing but voltage source. That's the way you have to identify the element in the circuit. Okay. Next one, the basic terms associated with the electric circuits. Now we are moving towards the electric circuit. So what are the types of circuits and how to solve the problems in the circuit? What type of analysis we have to go? For that we are going to see. So for that we must know the basic terms associated with the circuit. So the first basic term is nothing but circuit. When you call it as a circuit, if you're having a closed path for the current flow, then you say it is a circuit. A closed path for the current flow, then we call it as a circuit. Path. It is a single line of conducting elements. It is a single line of conducting elements that is represented by a path. Node. It's nothing but junction. It may be a junction of two or more number of branches joined together or otherwise elements joined together. That's why we are calling it as node. And branch is nothing but it is a separate element in a circuit. For example, this is a branch. Resistance, this is a branch, this is a branch, this is a branch, and this is a branch. So individual element in a circuit is called as branch. And loop also, it is a simple closed path for the current flow. And mesh and loop are same. So the basic equation with respect to the branch, loops and nodes is nothing but B is nothing but L plus N minus 1. N represents the number of nodes, L represents number of loops and B represents number of branches in this circuit. So all the circuits will satisfy this condition. B is nothing but the branches you can able to identify with the help of loops, nodes. Okay. So this is the basic equation for determining the value of number of branches in a circuit. Here I have given you an example of DC circuit. This is an example of DC circuit. Now here this R1, R3, R5, R4, R2, R3, R6 and R7. These are all elements in a circuit and voltage source. These are all various elements in a circuit. So these are all called as branches. Now here it is a meeting point of two or more elements. That means R1, R3 and R2 are meeting it here. So it is called as a node. Same way R3, R5 and R4 are meeting here. So this is called as a node. Now closed path for the current flow is called as loop. So this is one loop, this is second loop and this is third loop. So here there are three loops are available. 4 nodes and 3 loops are available. A number of branches 1, 2, 3, 4, 5, 6, 7, 8. There are 8 branches are available. Okay. So this is an example of DC circuit. Now same example, you just see the second example. Here I have asked you to determine the number of branches, nodes, and also identify what are the elements are in series and parallel that we have to identify for this circuit. So as you see the circuit, the number of branches is nothing but 10 volt is a branch, 5 ohm is a branch, 6 ohm is a branch, 2 ampere is a branch. That means there are 4 branches are available: 10 volt, 5 ohm, 6 ohm and 2 ampere. Now the nodes is concerned. It has 3 nodes. It has 3 nodes. See here, this can be considered it as a first node, and this can be considered it as a second node, and this can be considered it as a third node. Now, the 5 ohm resistor is in series with 10 voltage source. Why? Because the current, same current is flowing through this. 6 ohm and 2 ampere are in parallel with each other. This is the way we have to identify the different elements, and also you have to identify the number of loops and nodes in a circuit. You just take the example. How many branches and nodes does the circuit have? Identify the elements that are in series and in parallel. So for this, here the branches are 1 ohm, 2 ohm, 5 ohm, 10 volt and 4 ohm. There are 5 branches are available in the circuit. Nodes are concerned. This is one node, this is another node, and this is another node. So there are 3 nodes are available in the circuit, and the elements which are in series and parallel are 1 ohm and 2 ohm are in parallel, 10 volt and 4 ohm are parallel. This combination is in series with 3 ohm. Same way, this combination is in series with 3 ohm. This is the way we have to identify the number of nodes, number of branches, and also the identification of elements in the series and parallel. Okay. I hope you understood the today's session. Thank you.